Assalamualaikum, my name is Muaz Aiman, matrix number 169-390. The subject of my talk is Introduction. In the first part of my talk is study background. Generally, a shaft is a rotating machine element and circular in cross-section which is used to transfer energy from one part of the machine to the another part that consume energy. One of the applications that using shaft is internal combustion of the engine, and we call it camshaft. There are many cams mounted on the shaft, and the function is to actuate the valve to open and close for internal combustion process of the engine. The cam was set at particular angles mounted on the shaft so that the valve open and close in a prescribed sequence. In the second part of my talk is objective. First, we want to discover the best material for our camshaft for better performance. Secondly, we want to evaluate the usability and feasibility of the camshaft. Thank you.
I have summarized how camshaft works. The cam lobes travel up and down as the camshaft rotates, and the valve spring pushes the valve back up as the cam lobe rotates further. A fixed camshaft could open the intake valve 10 degrees before the top dead center and close it 5 degrees after bottom dead center, and open the exhaust valve 15 degrees before bottom dead center and close it 5 degrees after top dead center. Next will be the manufacturing process of camshaft. Camshaft will go into casting process if shell cast iron is used. Other way, it will go into forging process if it is made from steel. Next, machining is required in order to give the cam a final dimension. Next process, center drilling and turning on one side is done. Next, the turning for 6 channel is taking place. The following step is drilling, which the whole hole is drilled. Grinding and final grinding of the 6 channels come next. The next stage is the face grinding process that uses an angular grinding wheel. At drill the whole stage, cam grinding is performed here. For lapping, it is performed using lapping paper on the cams. The next step is slitting, which a slit on the right side of shaft is created. After that, the dust, grease, chips, and other parts are washed with water and air jets. Lastly, inspection will be done to monitor for the tolerances.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abid Faryuddin and I would like to talk about the design analysis of our camshaft for the V6 engine. So this is our design for the camshaft that will be used in a V6 engine. We made the design by using an Autodesk Inventor. This is the multi-view drawing that we made by using the Autodesk Inventor for our camshaft. As you can see, the camshaft got 3 pair of cams and each pair will work with one piston, which means in a V6 engine there will be 3 pistons on each side. Next, we made stress analysis on our camshaft by applying 403.85 Newton force to each tip of our cams in the camshaft. And this is the result on what happened on our camshaft by simulating it in the Autodesk Inventor.
My name is Muhammad Ilmi and today I'm going to talk about the material selection for our project. Using the CAS software, we have listed down 3 materials, which is the low carbon steel, low alloy steel and the cast iron. We have decided to use the cast iron as our main material. So in this graph we can see that the density for the cast iron is the lowest compared to the other 2 materials. Having low density can make our camshaft very light, and the price for the cast iron is relatively high. And in this graph, we can see that the Young's modulus and the tensile strength for the cast iron is the lowest compared to the other 2 materials. In this graph, we can see that the maximum surface temperature for the cast iron is higher than the low carbon steel but lower than the low alloy steel. And the castability for the cast iron is the highest compared to the other material. This is important because the cast iron need to undergo a process called chill iron casting so that its material properties can improve by a lot.
Hi, I'm Mohammed Ismori. So for the calculation part, here is the engine specification, camshaft dimension, and material use value for our calculation. First of all, we calculate the torque act upon the camshaft that produced by the engine by using the torque formula. We get the torque equal to 43.02 Newton meter. Next, we calculate the torsional load where maximum shear stress acting on the camshaft is calculated by using the shear stress formula. We get the maximum shear stress is equal to 0.0319 gigapascal. Next, we calculate the force acting on the camshaft due to the valve spring load. We assume that the force acting on the cam equal to the force acting on the spring. By using the spring force formula, we get the force equal to 403.85 Newton. Lastly, we calculate the safety factor by using the maximum shear stress theory, where we get the safety factor equal to 893.42.